Detectors at the bottom of the sea have registered neutrino O of record energy. Scientists report that February 13, 2023 underwater the KM3NET detector off the coast of Sicily recorded a record-breaking neutrino with estimated energy of 120 peta-electronics, PeV. Its source is not there still identified. High-energy particles are constantly reaching the Earth, but in 2023, scientists recorded neutrino coming from deep space with an energy much larger than previously detected neutrinos. In the released in the Nature announcement, its energy was estimated at 120 peta-electron volts, PeV. Although there is a wide margin of error in the case, this discovery, even with the lowest estimates, is the order of magnitude above all previous detections. Scientists focused on the KM3NET project detected this event. It was only at the beginning of 2024, when they completed the data analysis. About the record, the discovery was announced last year at a conference in Milan, but not they revealed the details. Neutrinos are ultralight elementary particles. It is not they have an electric charge, and a negligible mass allows them to travel to huge distances of billions of light years. They are created during a series processes such as radioactive decay, nuclear fusion at star centers, or as a result of supernova explosions. Although next to photons they are the most prevalent, the particles in the universe are still not known much about them. Neutrino not subject to the influence of magnetic fields and very weakly interact with its matter. Not bad enough, they are often referred to as particle spirits. They can penetrate most objects without leaving a trace. Matter seems transparent to them. Scientists estimate that by 1 square centimeter of the surface of our planet facing the Sun every second there are 65 billion neutrinos. Neutrinos is very hard to detect. This can be done with very sensitive detectors, accurately shielded from cosmic radiation and from natural radioactivity. These particles are captured in huge swimming pools deep below the surface, filled with water or other substances. Neutrinos rarely interact, but when this particle will hit the nucleus of atoms forming water or ice, a cascade is formed. Other particles, including electrons or muons, that emit light, the Cherenkov radiation. And these sensitive detectors are able to detect. One such detector is under construction, KM3NET, cubic kilometer neutrino telescope. This is an underwater telescope. The neutrino task of detecting a trace of neutrinos. Within the framework project has been built so far 2 sets of detectors at the bottom of the sea, the Mediterranean. UKOKk, Oscillation Research with Cosmics in the Abyss, is located off the coast of Toulon in France. The second ARCA, Astroparticle Research with Cosmics in the Abyss, built the coast of Sicily in Italy. There are still plans for the third detector that has a stray to be built near Pylos off the coast of Greece. KM3NET consists of a series of sensitive light detectors placed in plexia and anchored on the seabed at depth about 3,500 meters. These sensors capture the light emitted by high-energy, electrically charged particles like muons. They are constantly falling to the surface of the Earth. They are created when cosmic rays hit the particles of the atmosphere. From time to time, however, the cosmic neutrino, which hits the surface of the planet, also produces muons and a stream of others, the charged particles. Researchers have detected just such a muon with estimated energy 120 the PeV. In the publication, they indicate that this muon was most likely created as a result neutrinos interaction with even higher energy. They also add that the energy of these events are much greater than the energy of any neutrino detected so far. More than 28,000 were detected during the event of 2023. Photons when particles produced by the neutrino passage spread after the detector. Researchers indicate that the path of neutrino was almost horizontal relative to the Earth's surface, which means that the neutrino must have overcoming a lot of rocks and water in the Earth's crust before it hit the atom at range outant of km3 net. Based on high-energy particle and its almost horizontal trajectory, the team concluded that the muon was probably made not by cosmic rays, but by neutrino. High particle energy also suggests that the neutrino may have formed in a different space accelerator than previously recorded neutrinos of lower energies, or it may be the first detection of neutrino expired from cosmic radiation with ultra-high energy convening with photons of background radiation in the universe, ubiquitous the glow of the Big Bang.
Pas de soleil, pas de soleil, pas de soleil. Pas de soleil, pas de soleil, pas de soleil.